Today we're going to learn how to find the equations of lines and planes. Okay, different lines, equations of lines that's different from what you learned when you looked at two dimensions. What happened in two dimensions? How did you determine a line or find the equation? You needed either 2 points or you needed a point and a slope, right? That is what a line was determined by. But not so in three dimension. The equation of a line is actually a vector. It's in vector form, okay? And it is determined by a point and a vector parallel to the line called the direction vector. So you must have these two things in order to find the equation of the line. So let's look at the equation. So let P0, which is x0, y0, z0, be a point on the line L. Let V equals the vector ABC be the direction vector. So it's parallel to the line L. So what you have is something like that. Okay? So this is the line L. Okay? You want to find the equation of the line L. And of course, we're looking at vectors, so say it's in a particular direction, right? And P0 is a point, any point on the line, and then the vector parallel to L is the vector V. Okay? Then the equation of the line is R is just an arbitrary vector, is equal to the vector x0, y0, z0, which is the direction vector of the point, plus T times the direction vector. So I'll say it again. R is equal to, this is the position vector of the point P0 plus T times the direction vector of the line. T is a parameter, so T can take on any value. And as I said, R is the position vector of an arbitrary point on line L. This form of the equation is called a vector form or the vector equation of a line. From it, you can derive the other two ways that you can express an equation of a line. There are three ways. So there's the vector equation, then there's the parametric equation, and there's the symmetric equation. Let us look at the parametric equation. Let's find the parametric equation. So R is the position vector of any point on the line. So let's call it XYZ. So we substitute R with XYZ. And so let's write out the three equations when we look at the corresponding elements. So x equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. These are called the parametric equations. Note, with the parametric equations, the coefficients of t form the components of the direction vector. Okay? What about the symmetric equations of the line? You take the parametric equations and you just solve each of them for t. So when you solve, and t would be the same for each equation. So when you solve the first equation here, you get x minus x0 divided by a. The second equation, y minus y0 divided by b is t. The last equation, z minus z0 divided by c is t. Put them all equal to each other and you get the symmetric equations. Again, note the denominators here form, or the denominators form the components of the direction vector. And I'm telling you this because a lot of times when you see problems involving lines and planes, you have to pull out the direction vector from the equation of the line. So I'm showing you how to get it, okay? Nice. So let's do some examples. A line passes through the point 5, 1, 3 and is parallel to the vector I plus 4j minus 2k. We want to find the vector equation, then the parametric equations, then the symmetric equations of the line, and then we want to find two other points on the line. So the vector equation is always the easiest thing, so let's write that. So part A, part 1, the vector equation, make sure you put your R. R equals, the point goes first and you put it as a vector, the position vector. So I'll just use angle brackets. If you want to use ij and k, no problem, but do not mix the two. Don't use angle brackets and ij and k in the same equation, okay? So I'll put 5, 1, 3 plus t, and the direction vector, the line is parallel to this vector, so it's 1, 4, minus 2. So that is the vector equation. Now let's find the parametric equation. Part 2. So you want 3 equations for x, y, and z. So the corresponding x values, x is equal to 5 plus t. Corresponding y values, y is equal to 1 plus 4t. And then z is equal to 3 minus 2t. Any questions so far? And then finally, the symmetric equations, part 3, all you want to do is to solve for t in each equation and put the results equal to each other. So in the first one, t is x minus 5 as the first t, equals, next equation, what is t? Y minus 1 over 4 equals, last equation, what is t? Z minus 3 divided by negative 2. So these are the symmetric equations. Any questions? Now, how do you find 2 other points on the line? Now, remember when you did parametric equations, I think that was in Calc 2. You use this parametric equation to find points on the line. How? By substituting values of t. So, different values of t will give you different points on the line. So all you need to do is to take any 2 values of t, substitute it into any of those. I would suggest you, I think part 2 is the easiest one to substitute the t values in. That will be your point. Now note, if I put t equals 0, I get the point 5, 1, 3. We already have that point, so don't choose t equals 0. Okay? So maybe we can choose t equals 1. So t equals 1 gives you what point? 6, 4 and 1, 5, and then 1. And then take another value for t, and then you get another point. Shall we take, say, t equals, say, 2? Anything would work except 0, because you have the 0 already. T equals 2 gives us 7. 2 4s are 8 and 1, 9. 3 minus 4, negative 1. Okay, so that's the first one. Any questions on that? Okay. Let's do another example. Find the parametric and the symmetric equations of the line through the points 2, 4, negative 3 and 3, negative 1, 1. At what point does the line intersect the xy plane? Okay, let's find the equations of the line first. So here you're given the line passing through 2 points, 2, 4, negative 3 and 3, negative 1, 1. So this is the line, and let's say I know I'm in 3D, but I'm going to superimpose it in 2D, okay? To make it easier to view. All right, so we already have a point on the line. What else do we need to find the equation of the line? Tell me. Direction vector. We need the direction vector. Okay? So the direction vector is going to be your displacement vector. You remember how we do that? You subtract the 2 points, and that will give you the displacement vector. So the direction vector is equal to the displacement vector, and let's find it. So we subtract. You can subtract in any direction, it really does not matter. So I'll do the 3, -1, 1 minus the 2, 4, -3. So that would be 1, -5, and 4. That's not good. That looks like a 6, and I need angle brackets here. -5 and 4. So that's your direction vector. And now you can choose any point, because both points lie on the line, so you can choose any point for your equation. All right? So the let's start with the parametric equations. So you can put a note that we're choosing any point because both points lie on the line, okay? X equals, if I choose the point 2, 4, -3, so let me, maybe I will make that note, okay? Let's just write this again. Sorry about that. So I'm going to say choose any point, say 2, 4, -3, okay? So the parametric equations would be x equals 2 plus t, y equals 4 minus 5t, z equals -3 plus 4t. The symmetric equations let us solve for t. And what do we have? First equation says t is x minus 2 equals the y equation says t is y minus 4 divided by -5 equals. The z equation says that t is z plus 3 divided by 4. Any questions here? The next question, at what point does this line intersect the xy plane? Right, so a line intersects an xy plane, okay, at which point? First of all, what happens in the xy plane? Remember, I think it was the first lecture, I told you the xy plane is the same thing as z equals 0. Remember that? So therefore, you need to find out the value of t when z equals 0. Because if you want to find a point on the line, you need a value of a parameter, right? So when z equals 0, find what t is, and then you'd be able to find the point. Okay? So the xy plane says that z equals 0. So this means, okay, where is our z? Our z is -3 plus 4t. So -3 plus 4t equals 0. When we solve that, we get t is 3/4. So take this value of t, substitute it to find x and y. So t equals 3/4 implies that x equals, so go to your parametric equations with the x, 2 plus 3/4, which is 11/4. Y equals, our equation is 4 minus 5t. So that's 4 minus 15/4, which is 1/4. And z is 0, so your point equals 11/4, 1/4, 0. Okay. Okay. Any questions on that? Now let's look at number 3, which is, it has a little trick in it. Find the parametric and the symmetric equations again for the line through the point 2, 1, 0. And this line is perpendicular to 2 vectors. Line is perpendicular to both I plus j and j plus k. So we have a point on the line, but what we don't have is the direction vector, yeah? Now let me see if you can reason this out. This line is perpendicular to 2 vectors. I want to find a vector that is parallel to that line. Remember, the direction vector is parallel to the line. How can I do that? Cross product, beautiful. Beautiful. Why? Because remember, the cross product of 2 vectors is always perpendicular to the vectors. Remember that. So this cross product must be a direction vector for the line. Okay? So the direction vector is equal to the cross product of, say, I plus j cross j plus k. Now, these are the type of situations that I would let you use your calculator to get the cross product. You with me? Because it's within a question. I mean, I'm not telling you find the cross product. You understand? You have to know you have to find the cross product. So you can just put that into your calculator. Good? And then when you put that into your calculator, I think I worked it somewhere. You get I minus j plus k. And you can check I minus j plus k. Okay? So this is the direction vector. We have the point. Let us write out our parametric equations first. Parametric equations. So x equals 2 plus t. Y equals 1 minus t. And z equals 0 plus t. Z equals t. And then the symmetric equations, let's solve for t. First one, x minus 2 equals. Next one, t is 1 minus y. And tz. Okay? These are the type of questions you're going to see more of right now, where you have to reason out when to use the cross product and so on. Okay, any questions? Okay, so try this one on your own, please. So your direction vector, that is your displacement vector, rightly so, you get 11 minus 3, 0. You can use any point, it really does not matter. So if you use the point, (3, -2, 4), and you could have used -8, 1, 4 as well. Your parametric equations, x equals 3 plus 11t, y equals -2 minus 3t, z equals 4. So if you notice, there is no t in the last one. So therefore, when you are writing your symmetric equations, there is no t to solve in the last equation. So you just solve the first two. X minus 3 over 11 equals y plus 2 over minus 3. That's all you can solve for t. Okay? Put a semicolon and then put z equals 4 separately. Or underneath, wherever you want to put it. Any questions? Okay, let's just look at some properties of lines. We're first going to determine how we know whether two lines are parallel, and also how we find the point of intersection of two lines. So let's start with parallel lines. Very easy. Two lines are parallel if their direction vectors are parallel. So look at the following example and we'll see why the lines are parallel. What are the direction vectors? I minus 5j plus 4k is parallel to 2I minus 10j plus 8k. Can somebody tell me why they are parallel? Right, this one is a scalar multiple of the other. The second one, when you multiply the first one by 2, you get the second one. Okay? Since one is a scalar multiple of the other. So that's how you check whether the lines are parallel. All right? Any questions on parallel lines? Okay, intersecting lines. Now, go back to 2 dimensions. How do you find the point of intersection of two lines? What did you do normally? You did what? You put them equal to each other and you solve, right? So that's exactly what we're going to do here. But here you're going to solve for parameters. But the thing about this is that we now have 3 equations to solve. All right, so how do you do that? Okay, so I gave you a little note. To determine the point of intersection of two lines, equate the lines, solve for the parameters. If the values of the parameters are unique, the lines intersect. Now, a very important concept here. Lines which do not intersect and are not parallel are called skew. Okay, so you can have that happening. The lines, they do not intersect and neither are they parallel. Remember, we are in vectors, huh? So we are looking at certain lengths and certain directions, okay? You're not in 2 dimensions where the lines go on and on. Okay, so careful here, right? Okay, so let's do some examples. Determine whether the following lines intersect. So what we're going to do, and then I gave you the parametric equations for both lines. If I give you 2 lines, it is always best to put them in parametric equation form so that you can equate. All right? So what we're going to do, equate the x's, equate the y's, equate the z's, and then we're going to solve. All right? So for the x's, let's equate the x's, and we have 5 plus 2t equals 4 minus 3s. Okay, I'll bring the t's and the s's to one side, and so we have 2t plus 3s equals minus 1. Let's call this equation 1. Do the y's now. Minus t equals 1 plus 5s. This tells us that t plus 5s equals minus 1. Let's call this 2. And the third equation, minus 2 plus 3t equals 4. Now this is quite easy, right? Because the third equation, we can easily find what? T is. Good. So let's find T. This implies 3T equals 6, so T equals 2. Now take this value for T, put it into 1 and 2, and see if you get the same values for S. If you get the same values for S, then the lines intersect. If you do not get the same values, then the lines do not intersect, because S has to be unique, right? So substitute T equals 2 in 1 and 2. So 1 becomes 4 plus 3S equals minus 1. 3S is minus 5. S is minus 5/3. 2. 2 plus 5S equals minus 1. 5S is minus 3. S is minus 3/5. Not unique. So the lines do not intersect. Okay. Any questions on that? Let's do another one. Hopefully this one is going to intersect. Number 2. All right, so let's equate again. 3 plus 2t equals 7 minus 2s. That gives me 2t plus 2s equals 10. Or what am I saying? Sorry. Equals 4. I think I'll divide everything by 2. So that gives me T plus S equals 2. Hopefully that's going to help me. Do the y's. Minus 2 plus 5t equals 8 plus S. That gives me 5t minus S equals 10. The second one. The last one. 1 minus t equals minus 1 plus 2s. That gives me t plus 2s equals 2. Third equation. Now, how do you solve 3 equations with 2 variables? There are many ways to solve them, but for your purposes, you take any 2 of the equations, okay? Because you know how to solve 2, right? So you take any 2, the easiest 2 obviously, solve for both of the parameters. When you have done that, substitute these values into your third equation. If it satisfies the third equation, then you're done. The lines intersect. If the parameters do not satisfy the third equation, then the lines do not intersect. Okay, so let's see, which 2 are we going to choose? Let's choose the first and the second. I think we can add these 2. Okay. Solving 1 and 2. So we add, and we get 6t equals 12. So t equals 2. And then take this 2 and find what s is in any 1 and 2. So t 2 plus s equals 2. So s is 0. So these are the values that we get when we solve 1 and 2. Now take these two values, put them into 3, and see if they satisfy 3. So I'm going to say check in 3. So t plus 2s equals 2. T plus 2s equals 2. Does that make sense? Let's put 2 for t and 0 for s. And is that true? So 2 plus 2 times 0 equals 2. That is true. Okay? So we're done. The lines intersect. So the lines intersect where either t is 2 or s is 0. Use any one of these values to find the point of intersection. So take either t equals 2 or s equals 0, put it into the equation of the line up there, and that will give you your point. So I think it's easiest to take s equals 0 and substitute. So when you put s equals 0 into these 3, you get 7, 8, negative 1. That's the point of intersection. Okay? So put s equals 0 into L2. Point of intersection equals 7, 8, negative 1. And that's that. Any questions? Yes. You can use I because you can use either one of these to get a point of intersection. You don't have to use both. You with me? So you can either use t equals 2 or s equals 0 and you'll get a point.
Can you use other methods for solving that system, or do you have to use the substitution like that? Could you put it into a matrix?
Yes, you can. Yes, you can. You can use matrices to solve that system. If you know that. Yeah, that's a good idea. Okay, so I think it's your turn, isn't it? Yes, your turn. Try these. So determine whether the lines intersect. If they intersect, find the point of intersection. Okay, so the three equations that you should get when you equate x, y, and z are t plus 2s equals minus 2, 2t plus 2s equals 0, 2t plus s equals 2. You may have had them in different forms, 1, 2, and 3. When I solve 1 and 2, you should get s equals 2. Sorry about that. You should get t. Okay. All right. T equals 2 and s is negative 2. And check in 3, it works. Because 4 minus 2 is 2. So that's true. And so the point of intersection, you take any of these values for s and t, put it into the lines, and you will get 2, 5, negative 1. Any questions? So now let us look at the equation of a plane. Now for you to find the equation of a plane, you need to know the normal vector to a plane. And what is the normal vector? It is a vector that is perpendicular to the plane. That is, what do we mean by that? It is perpendicular to every displacement vector between any 2 points in the plane. And it is usually denoted by n. So let me show you what I mean. So let's say this is a plane. And this is the normal vector. Put it in red. Okay, so this is n. So this vector is perpendicular to every displacement vector in the plane. So this is a vector, so it's perpendicular here. It's perpendicular to this vector, and so on. Any vector, any displacement vector in the plane. All right, so that's a normal vector. So how do you find the equation of a plane? As usual, is determined by a point and the normal. So that's what you need. That's what you need to find the equation of a plane. So if you have a normal vector ABC to a plane, and any point x0, y0, z0 lying in the plane, the equation of the plane is as follows. A times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. Very important formula. You can outline it. It's something that you will need. Let's do some examples. Find an equation of the plane through the point 2, negative 4, 0, and with normal vector I plus 2j plus 3k. So the equation would be, well, you want the coefficients of the I, j, and k. So 1, I'm going to put the 1 so that you will understand what I'm doing. 1 times x minus 2 plus 2 times y minus minus 4, so that's plus 4, plus 3 times z minus 0 equals 0. Distribute, and then you get that x minus 2 plus 2y plus 8 plus 3z is 0. And so x plus 2y plus 3z equals minus 6. That's the equation of the plane. Note, again, I want to point out these things to you because it will help you when you get these problems, word problems. When you have an equation of the plane, the coefficient of x, y, and z would be the normal. Notice that. Okay, coefficient of x, y, and z would be the components of the normal. Let's do another example. Actually, it's your turn. Find an equation of the plane through the origin and perpendicular to the vector. Let me see how you'll handle that. Okay, let's go over that one. It's quite easy. So a plane, again, we need a point and the normal, right? When we find in the equation of the plane. We already have the point, which is the origin. What is the normal? What's the normal vector there? What's the normal in this question? What's the vector that's the normal? 1, negative 2, 5. Yes. Why? Because the normal vector is always perpendicular to the plane. Right? So if this vector is perpendicular to the plane, then this is the normal vector. And so your equation would be 1 times, go ahead, give it to me. Yes. Very good. So this gives me x minus 2y plus 5z equals 0. So that's the equation of a plane. So you need to be able to decipher these things, understand, you know, how to pull out the normal, how to pull out direction vectors. Very, very important. Next concept. Let's find the equation of a plane through 3 points PQR. Again, to find the equation of a plane, you need the normal vector and a point. How do you find the normal vector? Use the fact that the normal vector is perpendicular to every displacement vector in the plane. So you find two displacement vectors and that's sufficient. So we can find PQ and PR. Now, how do you find the normal? The normal has to be perpendicular to these two vectors. You know cross product of these two is perpendicular. So therefore, the normal would be the cross product of these two vectors. So that is how you find the normal. Cross product of PQ and PR. And then, so use the general format, which you just saw. Use the normal, N, and you can use any of the points, P, Q, and R, to find your equation. So let's do an example. Find an equation passing through the points 0, -2, 0, 4, 1, -2, and 5, 3, 1. Okay, I would advise that you label these points. So P, 0, -2, 0, Q, 4, 1, -2, R, 5, 3, 1. Now let us find two displacement vectors. Okay? And we're doing it the same way. I think we did questions like that previously. Make sure you choose the right displacement vector. So you have to choose displacement vectors where you have common points. Okay? So I'm going to choose PQ and PR. So PQ, we subtract and we get 4, 3, -2. PR, 5, 5, 1. So we have two displacement vectors. Now, the normal vector N is the cross product of PQ and PR. So enter these into your calculator and tell me what you get. What did you get? 13, -14, and what else? 5. Make sure you got that. So that's your normal. Now you choose any point and use the equation that we just saw. Alright, the formula that we just saw to find the normal. I think the easiest point to use there is P because we have a bunch of zeros. Okay? So let's use it. So the equation of the plane alright, so it would be 13. I'm going to use P, okay? So use P. 13 times x minus 0 minus 14 times y plus 2 plus 5 times z minus 0 equals 0. Now we distribute that. 13x minus 14y minus 28 plus 5z equals 0. And our final answer, 13x minus 14y plus 5z equals 28. That's that one. Any questions? Okay, so you try the other one now. It's your turn. And as I said, I would advise you all to label these points, okay? It would help you quite a bit. So you can put P 211, Q 041, R negative 214, and then you can find your PQ, PR cross products and find the equation. Okay, one person give me PQ, please. One person give me the displacement vector PQ. Go ahead. Good. Somebody else give me PR, please. Negative 403. Somebody else give me the normal vector, which would be the cross product of the two. No, that doesn't look good. Thank you. And then somebody else take it away, the equation of the plane. Mm-hmm. And when you simplified all of that, what did you get? 9x plus 6y equals what? 36. Good. And you can simplify that further to 3x plus 2y plus 4z equals 12. Any questions on that? Okay. Next concept in planes. The angle between two planes. And that's quite simple. The angle between two planes is just the angle between their normal vectors. And you already know how to find angle, right? Using dot product. So that should not be too difficult. So let's just do one example. Find the cosine. We just want the cosine of the angle between the planes. X plus y plus z equals 0. And x plus 2y plus 3z equals 1. So what you need to write down are the normal vectors. So can somebody give me the first normal? 1, 1, 1. Can somebody else give me the second normal? 1, 2, 3. Okay? So now we need to find the angle between these two vectors. So let's recall dot product. That's what we did the last time, right? So we need n1 dot n2. And that is 1 plus 2 plus 3, which is 6. Then we need the length of n1, which is the square root of 1 plus 1 plus 1, which is square root 3. Oops, not much space. Then you need the length of n2, which is square root of 1 plus 4 plus 9, which is square root 14. And so the cosine of theta, using our formula, is the dot product 6 over square root 3 times square root 14, which is 6 over square root 42. That's all we need. They didn't ask us for the angle, they just wanted cosine. Okay. Any questions so far? Next concept. Point of intersection of a line and a plane. Again, how do you find point of intersection? By equating, solving, substituting. So what we do, we substitute the equation of the line into the equation of the plane and solve for the parameter and use that parameter to find the point of intersection. Okay, so this should be nothing too difficult. Let's do an example. Find the point at which the line with equation x equals 3 minus t, y equals 2 plus t, z equals 5t, intersects the plane x minus y plus 2z equals 9. So we have expressions for x, y, and z. So take these expressions and put them into the plane. Okay? So put 3 minus t for x, minus y is 2 plus t, so minus 2 plus t, plus 2 times z, which is 5t, equals 9. And all you're going to do is to solve for the parameter t. So 3 minus t minus 2 minus t plus 10t equals 9. The t's, that becomes 8t, that's a plus 1 equals 9. 8t is 8, so t is 1. So t is 1. How do we find the point now? You tell me. Put it into x, y, z. Okay? And so the point of intersection equals 2, 3, 5 upon substitution into the parametric equations. That's that. The distance from a point to the plane, I will just give that to you. I will not do too much on it, but this is just a formula that if you have a point P and you have a plane, this is the formula for the distance. And then if I give you two planes and you want to find the distance between two planes, you choose any point on one plane and find the distance from that point to the other plane. What is more important? Let's look at the line of intersection of two planes. Now, when planes intersect, they intersect on a line. Okay, so this is extremely important. Find the parametric equations of the line of intersection of the two planes. Oh, there's a little error there. X plus y plus z equals 1 and x minus 2y plus 3z. I think that should be equals 1. Just let me check. So equals 1. Okay. Now, the line of intersection of these two planes. When we want to find the equation of a line, what do we need? Tell me. There are two things we need to find the equation of a line. What are they? Now, normal has nothing to do with a line, so we need a point on the line, and what else? Direction vector. Okay? We'll look at the point later. Let's look at the direction vector. The line is in the plane, right? That means the line is common to both planes. You with me? So the direction vector of this line should be perpendicular to what? Okay, let me ask it another way. Let me ask it in a broader way. How can I find the direction vector of that line? Given two planes. Think about it. Go again. Now, you know you have two planes, right? Now, if you're given two planes, you know you have something to do with the normals, don't you? Okay? Think of the two planes. Two normals, both of these normals. What are normals? Normals are perpendicular to planes, right? Right? If I take the cross products of these two normals, what do you know about this particular vector? It's what? It's perpendicular to these normals, right? And if the cross product is perpendicular to these normals, that cross product should be parallel to the line, because the line is the intersection of the two planes. Let's write that down. So N1, 1, 1, 1. N2, 1, negative 2, 3. The direction vector is equal to N1 cross N2. Could you work that out for me? I want to make sure you can do these things. N1 cross N2. When you have it, tell me.
Negative 2, negative 3.
Tell me.
5, negative 2, negative 3.
5, negative 2, negative 3. You do this so quickly. Okay. We have the direction vector. Now we need a point on that line. Good. Now, remember the line of intersection is common to both planes, right? So any point that lies on that line also lies in the plane, in each plane, right? So what you need to do, it's like you are solving the two planes. You're trying to find a point that would satisfy these two planes. As if you're equating them, you're putting them in equal to each other. That's exactly what you're doing. Okay, now there are different ways to do that. I mean, you can do it the long way, but I'll give you a very short way to find the point. Choose any arbitrary value for z, or for any of them, x, y, or z. Okay? But we normally choose 0 because it's easy to plug in 0. So you choose a z equals 0, put that into the plane, and that will enable you to find the values of x and y. So that's an easier way to do it. You can equate the two planes, put them equal to each other, and then you will get an equation with x and y that you can solve by putting parameters. You can do it that way. It's a very long method, but I think the easier method is to just choose z equals 0. So let's find the point. So find the point on line. So choose z equals 0, substitute it in the planes, we get x plus y equals 1, x minus 2y equals 1. Now you solve these two equations. What do we get? I think we can subtract. When we subtract, we get 3y equals 0. So y is 0. And you're going to get that x is 1. So your point is 1, 0, 0. Okay. Now, did I ask you to find what did I ask you to find? Parametric equations? Okay. So we have the point, we have the direction vector. So the parametric equations, x equals 1 plus 5t. Oops. Not much space then. Sorry about that. Y equals 0 minus 2t. Z equals 0 minus 3t. That's it. Any questions? Okay, that's it.